So for this problem, we have a function f which gives the voltage across a capacitor as a function of time t in seconds, and we want to write a sentence that describes each of these mathematical expressions below. So the first expression is f of t plus 5 minus f of t. So notice that we're talking about two y values here, and we're subtracting them. So we're really just finding the change between two y values. But in the context of this problem, that would be finding the change in voltage during the time period t to t plus 5. So given any time t and 5 seconds later, we're finding the change in voltage during that time. So the next one is f of t plus 5 minus f of t over 5. So the thing to note is that this is a rate of change. This is like y2 minus y1 over x2 minus x1, where our x2 minus x1 would have been t plus 5 minus t. Well, that just leaves us with 5 once you cancel out the t's, which is exactly what we have here. So we know that we're looking at a slope, essentially. So since we're looking at slope, we're finding the rate of change, and in this case, we're finding the average rate of change during the time period t to t plus 5 seconds. And then so for this last one, we're taking the limit as delta t approaches 0 of f of 5 plus delta t minus f of 5 over delta t. So same thing, this is a rate of change that we're taking the limit of. And the thing to note is that this is talking about an instantaneous rate of change, because the difference between f of 5 plus delta t and f of 5 is going to be very small, because delta t is going to 0. So we're essentially saying, like, when x equals 5 and x equals 5.001. It's something very, very small, and we're taking that limit, so we're getting closer and closer. So we're taking a instantaneous rate of change. So we're going to say that this represents the instantaneous rate of change of the voltage at time t equals 5 seconds after the capacitor started being charged. Charged.